Finally, ISRO has launched its much-anticipated L1 solar mission. After the remarkable success of Chandrayaan-3, ISRO's ambitious ventures continue unabated. Their latest endeavor involves a daring mission to the Sun, with plans to dispatch a specially equipped Spacecraft rocket that will diligently study our star for a period of 5 years, providing invaluable insights. However, it's important to acknowledge that this mission presents a unique set of challenges. Unlike Chandrayaan-3, there won't be a solid ground to land on, nor will there be an orbit around the Sun to rely on. In this mission, Aditya L1 will remain stationary in a fixed position in space, right in front of the Sun. It's quite a remarkable feat to fathom, as maintaining such a static position in the midst of space poses an immense challenge. Now, envision the trajectory Aditya L1 must follow to achieve this stationary positioning. Understanding this trajectory is vital, as it greatly differs from the approach employed in our Chandrayaan-3 mission. And speaking of objectives, have you ever wondered what the primary goal of the Aditya L1 mission actually is? If India successfully accomplishes this mission, it raises some intriguing questions. What will India be called? How will Aditya L1 be launched? And what trajectory will it follow? Once it reaches the Sun, what will it study, and how will it conduct its research? Additionally, what are the limitations of this mission, as acknowledged by ISRO themselves? We'll delve into all of these details in this video. So let's not delay any further. First and foremost, let's address the significance of this mission. Why does it matter to us? To put it simply, this mission has the potential to become a historic achievement for both ISRO and India as a whole. You see, in general, solar missions have a success rate of less than 50%. To put that in perspective, out of the 77 space agencies around the world, only 3 NASA, ESA, and JAXA have launched solar missions, and those were typically conducted in collaboration with others. However, ISRO's Aditya L1 is a truly independent mission. This means that from its inception to its launch, international involvement is minimal. If you're wondering why previous solar missions have had a high failure rate globally, the main culprit is often unstable communication. ISRO, being aware of this critical issue, has taken it into careful consideration. In the case of Aditya L1, the likelihood of encountering this problem is significantly reduced. This is because Aditya L1 will be stationed to observe the Sun at a point approximately 1.5 million kilometers away from Earth, which is only about 1% of the distance from the Sun itself. In essence, Aditya L1 will maintain a safe distance from the Sun, ensuring that we don't have to compromise the integrity of our research data. Additionally, my friends, there's another compelling reason why this mission holds immense significance for India. With this venture, ISRO is entering the realm of space observatories for the very first time. Space observatories, in essence, are missions stationed in space to observe celestial objects like stars. Think of the James Webb Space Telescope just as an example. Prior to this, only 4 space agencies worldwide have successfully launched their own space observatories into the cosmos. Now, ISRO is poised to become the 5th space agency to achieve this feat. And last but certainly not least, this mission has the potential to make ISRO the first space agency to unravel the enigmatic 150-year-old mystery. Has not only perplexed our scientists, but has also left them somewhat follically challenged. Consider this scenario: when a car is approaching you, which perspective allows you to better gauge its speed, a first-person view or a third-person view? Clearly, it's the third-person perspective. This analogy highlights why relying solely on Lagrange point alone for space weather forecasting is insufficient. Another critical point raised by ISRO is related to the sun's poles, where important processes contribute to the sun's magnetic field and the associated coronal mass ejections, SEMSA. To study these poles effectively, solar probes would need to orbit the sun vertically, a highly challenging technological feat that hasn't been attempted yet, including by Aditya alone. In essence, despite Aditya alone's advanced capabilities and its advantageous viewing location, a vertically orbiting solar probe is still needed for accurate Kime ejection prediction and space weather forecasting. However, this doesn't mean that ISRO has abandoned its planned missions for Aditya alone. In fact, by acknowledging these limitations, ISRO is signaling its commitment to addressing these challenges in the future. Their strategy may involve initiating missions to gradually overcome these shortcomings, recognizing that once they gain momentum, they can achieve in greater success. Furthermore, the funding aspect is crucial. ISRO likely aims to demonstrate its capabilities and accomplishments with Aditya alone to secure more substantial funding for larger projects. Regardless of the specifics, it's worth noting that ISRO's Pragyan rover has recently started transmitting signals from the moon, operating beyond the Vikram lander, which is an exciting development. Thank you for watching the video.